Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, today we are starting a new topic. His name as Macaulay's double integration method. In that we are seeing how to find the slope and deflection by using double integration method. Let's see in details. Now see friends, this is a question given to you using Macaulay's method. Determine the slope at A. We have to find slope at A and deflection at C. Means slope at A and deflection at C. These two are the unknowns for us for the beam loaded as shown by using Macaulay's method. Keep remember the name by using Macaulay's method. Macaulay's method is also known as double integration method. Okay. Now in that we have to follow the certain steps. What are the steps? Let's see. Now see, start with the solution. First what we have to do, first draw the diagram first as it is. Now see, this is your, now this is a hinge support. This is a hinge support. It have two reaction, 1 and 2. This is ruler support and 1, but we are solving beam, that's why we don't need to H distance, H force. Okay, so first draw over here like this. This is your VA, this is your VB, this one is A, this is B, this is C, and this one is D. Now what to do first? See, now our first step is nothing but our first step will be reactions. First we have to find the reaction. Now how will you find the reaction? Taking moment at A equal to 0, clockwise positive. See, we have to taking moment at A, so 15 into 2 plus 15 into 2 plus 10 into 4 minus VB into 6 equal to 0. So this VB into this distance, VB is equal to 6. Now while solving this you get the value of VB. Your VB will be 11.67 kilonewton. Okay, now after that summation Fy equal to 0, upward positive. Now you got the value of VB will be 11.67 kilonewton. Okay, now Fy is this VA minus 15 minus 10 plus 11.67 equal to 0. Now you get the value of VA will be 13.33 kilonewton. Okay. Now what the Macaulay's method says, as you all know, Macaulay's method takes a section extreme corner of the beam. Extreme corner means either you can take section over here and this is origin, either you can take section over here and this is your origin. Always take the extreme corner, means we have to take all the loads simultaneously. Okay, we have to take all the loads. Now see, now you are taking section over here. Now what's Macaulay's method says, we are taking section either left or right, which is extreme corner, means we are taking section over here like this. Then this is your x, just xx. Now this distance is nothing but x. This is nothing but your x distance. Now what you have to do is, by using Macaulay's method, you have to find the bending moment over in this point, this sphere, and we have to see in this part over here. So now what is our next step will be? Let's see. Our next step will be number 2. Number 2 will be by Macaulay's double integration Now next step will be by Macaulay's double integration method. In that, taking A as origin, the bending moment at any section x at a distance x from A. Now this point you have to remember over here. By Macaulay's double integration method, taking A as origin. Now see, we are taken A as origin. This is your origin. The bending moment at any section x at a distance x from A. Now bending moment at any section means we are taking section over here and taking origin as A. Now we have to take the bending moment over here and see this side only. We have to take all the loads. That's Macaulay's say for us. Okay. Now see, after that, what is our next step? Now we are taking the section. Now we have the considering this part XA. Now consider part XA. Now in XA part, what are the sign conversion? As you know, in bending moment, to find the bending moment, the sign conversion is like this: sagging positive, hogging negative. Okay, these two are the sign conversion over here. Now after that, what you have to do here? Is see, if you are taking, see, this is your origin A. So just extend this some part and write it over here. Write one box over here and write x is equal to 0, because this is origin. So we are starting with the 0 and extend this part also and made one box and write it over here. X is equal to 2. See, this is coming from 0 to 2, that's why it will get 2. Now see this part also like this, extend some part, take one box and write it over here. X is equal to 4. Now write it over here, extend this part, make one box over here, write it. X is equal to 6. Now why we are writing these things, I am explaining after that. Okay, now just write. See, if you are taking section over here, this is your origin, write x is equal to 0, then 2, then 4, then 6. Okay, now after that, let's start with the solutions first. Consider part XA. Now we are considering part XA. Now bending moment at x is equal to EI d square y upon dx square. This is given to the Macaulay's force. Okay, EI d square y upon dx square. Now what are the value come over here? See, now we are taking bending moment over here and we are seeing this side. So this is going to this direction. Okay, so 13.33 into this distance is nothing but x. So 13.33 into x. Okay, 13.33 into x. After that, this 15 is going this direction, so this is going in this direction. So we want this distance. Then what is this distance over here? X minus this distance is 2. So 15 into x minus 2. 15 into minus 15 into x minus 2. Okay, now after that, this will coming, this 10 is coming, so minus 10 into x minus 4. 10 into x minus this distance will 4, we got this value over here. After that, this x minus 4. Now this is nothing but your equation number 1. Now see friends, we have done with this part, equation number 1. Now we are taken over here bending moment in this distance over here. Okay, now we have done this part. After that, as the name indicates, Macaulay's double integration method, now we have to this equation we have to integrate 2 times. Now let's start. Now how will integrate? Right over here, integrating with respect to x. Now we have to integrating with respect to x. Okay, now what is come over here? Come over here, we have to integrate over here. This will come ei dy by dx is equal to, now see, now dy by dx over here, see, this is nothing but 13.33 into x square by 2. This is a derivative, sorry, integration of x square by 2. After that minus, see, in Macaulay's method, don't split the value in terms of, so don't into the brackets, don't open the bracket over here. In Macaulay's method says don't open the bracket. 15 into x, 15x minus 30, don't do these things. Okay, always read this value as a x minus 2 is nothing but 1x. Okay, so what will come? 15 into x minus 2 the whole square divided by 2 minus 10 into x minus 4 the whole square divided by 2 plus c1, equation number done with 2 only. Okay, equation number 2. Now after that again integrate, again integrating with respect to x. Now we have to integrate again, as the name indicates, we have to integrate 2 times. Okay, so it will come over here ei y is equal to, now see, this is, now we have to integrate this part. Now 13.33 into x raised to square upon 2. What is the integration of, now what is integration over coming over here? 13.33 into x raised to 3 upon 6, x raised to n plus 1 upon n plus 1. Okay, now see, minus 15 into x minus 2 raised to 3 upon 6 plus, sorry, minus 10 into x minus 4 raised to 3 upon 6 plus c1x plus c2 plus c1x plus c2, equation number 3. So now we have done with this part over here. Now we have done with part of double integrate. We have integrated 2 times already. Okay, now after that our third step will be to find the value of now c1 and c2. So our third step will be to find c1 and c2. To find c1 and c2, applying the boundary Now see, to find the C1, C2, apply the boundary condition. Now what is the boundary condition? As you given in this, these are the boundary condition, means where we have to find reaction, this is a boundary condition. See, A and B are the boundary condition. That's why I am taking this X. When we are taking boundary condition, means you are taking this A as your boundary condition and this supports is your boundary condition. Means in exam, whatever reaction part is there, this is just nothing but this is nothing but boundary condition. Means this is a border and this is also a boundary condition. Okay, these two are the boundary condition over here. So we have to apply one by one. Now see, this is the first boundary condition. So write it over here, at x is equal to 0 and y is equal to 0, put in equation 3, equation number 3. Now see, put x is equal to 0. Here the value of x will be 0. And what about the deflection? But at corner deflection is always 0. That's why we are taking x is equal to 0 and y is equal to 0. Put in equation number 3. And this is our equation number 3. So this y is 0 means it will come over here 0. 0 is equal to 0 minus 0 plus C1x, x is also 0, so it will also get 0, plus C2. Now you got the value of C2. The C2 value will be 0. Okay. This is our first boundary condition. Now what is our next boundary condition will be? See, next boundary condition is this, means x is equal to 6 and y is equal to 0. Now x is equal to 6 and y is equal to 0. Put in equation 3. Okay, so it will come, see, 0 is equal to 13.33 into 6 raised to 3 upon 6 minus 15 into 6 minus 2 raised to 3 upon 6 minus 10 into 6 minus 4 raised to 3 upon 6 plus C1 into 6 plus 0. Now while solving these, you get the value of C1 will be minus 51.09. C1 value will come over here minus 51.09. Okay. Now after that, put the value of C1 and C2 in equation 2 and equation 3. Now we have got the value of C1 and C2. After that, put the value of equation 2 and 3. Now how will you put? Now put the value of equation 2 and 3. Now what is our number 2 equation? See, our number 2 equation will be here. This is your number 2 equation. So put it over here. What is coming over here? EI. See, EI dy by dx. EI dy by dx. Okay. After that is equal to, see, 13.33 into x square by 2. 13.33 into x square by 2 minus 15 into x minus 2 raised square upon 2 minus 10 into x minus 4 the whole square divided by 2 plus C1, but we got the value of C1 will be minus 51.09. okay, 51.09. so over here and take a equation number A. Take it as a equation number A. This is nothing but your journal slope equation. Journal slope equation means okay. Now after that, see, this plus minus will get minus over here. So 13.33 into 3x square by 2 minus 15 into x minus 2 square by 2 minus 10 into x minus 4 square by 2 plus we simply just put the value of C1 over here minus 51.09. This is nothing but A. This is named as A and this is nothing but your journal slope equation. Now in Macaulay's method we have to find journal slope equation and journal deflection equation. After that, now we have put the value in 2. Now put the equation in 3. And this is your 3 value. The 3 value will be this. Here this is your 3 equation. So put it over here also. So how it's come? It's come like EI y is equal to 13.33 x raised to 3 upon 6 minus 15 into x minus 2 raised to 3 upon 6 minus 10 into x minus 4 raised to 3 upon 6. Okay, plus C1 value will be minus 51.09 plus C2 will be 0. Equation B. Now see, B. This B is nothing but this B is nothing but your journal deflection equation. This is your journal deflection equation over here. Okay, this is your journal deflection equation. Come over here. This is named as B. Now we got the journal slope equation and journal deflection equation. After that, at any point we can find the slope and deflection, whatever asked in the exam. Now our fourth step will be. See, these two are the means. See, please listen carefully, students. These two equations are the main. This is journal slope equation. This is journal deflection equation. These two equations are same. These two equations are important for us now. Now we have to find now in question Now see in question what we are asking here, slope at A. Now we have to find slope at A. Slope at A means number 4. To get slope A is theta A is nothing but slope at A. Okay, now to get theta A, what we have to do, see, simply see at A what are the value of x? See, simply see what is the value of A over x. This, sorry, x value over A will be 0, so put x is equal to 0 in equation A, means theta A will be dy by dx. Means see, we have to put the value in A equation. What is equation? A will be general slope equation, means if you have to find at any point the slope, we have to put in this equation. If you find deflection at any point, we have to put in this equation the value of x only. Okay, here we have to put the value of x will be 0 in this equation. See, now how will you get? See, take one note over here. Take one note over here. This is a note for all of you. Note. And what the note says, in bracket minus sign, consider whole part as 0. Okay, if one term is 0, now see, this is a notes for all of you. So to get theta A, we have to put the general slope equation. But what Macaulay says, in bracket minus sign, consider whole part as 0. If in bracket we got the value negative, at that time we have to consider all the part is negative, all the part is 0. If one term is 0, consider whole part is 0. If one term is 0, in that part take whole part is 0. This Macaulay says over for us. Now see, we have to apply in A equation. So what is in A equation? See, EI dy by dx we are finding at A is equal to C. What is it? Just come, EI dy dx is nothing but theta A. So EI theta A is equal to C. This term we have to putting the value of x will be 0. See, this will get 0. This is also have x value have 0. This is also directly 0. All still always come. This one is only coming. See, this is x, this is x, this is also x. Means this 3 terms will get 0 over here. 0 minus 0 minus 0 minus 51.15. We got only the 51.09. Sorry, 51.09. Okay, 51.09. Now you got the value of theta A will be 51.09 upon EI. This is nothing but minus. So what is the unit over here? Radians. Okay. Now we got this value. EI will be 51.09. 51.09 with respect to radians. The unit will be radians. Now our next step will be fifth one. Fifth one, to get YC means deflection at C. Now we have to find deflection at C. At that time what we have to do, we have to find C. We have to find deflection at C. C will be, x value will be 2. So put x is equal to 2 in equation B. Okay, in equation B, because B equation is nothing but your general deflection equation. Your B equation is nothing but general deflection. We have to find the deflection, so use this equation. So EIY EI YC is equal to, see, 13.33 into upon 6. Okay, 13.34. Okay, now see, 13.33 into 2 square upon 6. 2 square upon 6. Sorry, this is not square, this is cube over here. Square upon 3. Now after that minus. Now see, this x value will be, what is x value over x value will be 2 minus 2 will get 0 over here. So this get directly cancelled. And this also get 2 minus 4 get minus 2. This is also directly 0. Now this is coming. A minus 0 minus 0 minus 51.09 into 2. Okay. Now we get the value of YC will be, now see, where we get the value of YC will be minus 84.4 by EI. And what is the unit of this? Nothing but mm. Minus sign indicates it's going downward direction. Okay. Now see, now we have done with this part. See, in exam we have to find theta at A. Just remember one thing in Macaulay's method. If you are writing this one, if you have to find the slope at A, just put x is equal to 0 in general slope equation. If you are finding deflection at D, simply put x is equal to 4 in general deflection equation. If you are finding slope at B, just simply put x is equal to 6 in general slope equation. Okay. I hope you understand my video, and don't forget to subscribe the Ekeeda channel. Thank you so much.